Dear students, till now we have seen how to define differentiation mathematically. It is a ratio of change in function to the change in basic quantity with a particular limit, and how to choose that limit or how to define that limit. For that we will see. Students, suppose this is a displacement time graph, okay, and this is the random behavior of any object, okay. I mean, with the time, how displacement changes. I have taken this random graph. If you see clearly, the theta is different at different point with respect to x-axis, then you can say the value of slope is different at different point. But if I ask you to calculate the velocity at this point A, how much is the velocity acquired by a body? Because velocity is what? The change in displacement to the change in time. So if I have to calculate the velocity at this point A, that means we have to calculate the slope at this point, because slope of the graph gives us the change in y-axis to the change in x-axis, and we have plotted on y-axis displacement and on x-axis a time, okay. So how we will calculate the slope at this point A? Because I have already explained, it is not so much easy to calculate the slope at this point, because in order to calculate the slope at this point we have to make a right angle triangle. Then it should be easy to calculate the slope. How you make a right angle triangle exactly at this point? Okay, to understand that or to calculate the slope exactly at that point, what we do, we simply take two nearby points compared to this particular point A. So if you draw a perpendicular on this x-axis, it intersecting at this point, let's call this point as T1. So near to T1 we take 2 points at equal distance. So let's say this is intersecting at point B and this particular point intersecting at point C. So if you see clearly, this is almost at equal interval. Now what we do, if I join or with the help of these 2 points, if I make a right angle triangle. So this is a right angle triangle. Now if I ask you to calculate the slope of this right angle triangle, this is what? A theta. Okay, so it is easy to calculate the slope of this right angle triangle. But when you calculate the slope of this right angle triangle, that is perpendicular by base, is it the slope of this point? No, because here theta is different, here theta is different. So we will not get the exact value of this slope. So what we do, we keep on reducing the size of this triangle. That means initially we have taken the point at this point and this point. Now we are trying to push this point towards left and this point towards right, okay. Or you can say I am reducing this delta t, that is this time interval and this time interval difference. Let's call this TF, and this is, let's call this TF, and this is TI. So what I am doing, I am reducing this TF minus TI. This is TI, this is TF. So I want to reduce the size of this triangle. How we reduce the size of this triangle? I am taking a point near to this point, let's say at this point. Here I am also fixing the point at this point. Now look at this triangle, the size of the triangle is now reducing. This is like that, okay. But if I calculate, this is what? Perpendicular, this is what? Base, perpendicular by base ratio, but that will gives us the theta at this point. But we want to calculate our slope at this point. So how we will calculate the exactly slope at this point? Again we reduce the size of this triangle. Now we will keep on reducing this delta t, delta t, delta t, so that exactly we are reaching at this point of graph where we are actually interested to calculate the slope. So here I have already explained how you define your differentiation, the change in function to the change in basic quantity, that will gives you the delta y by delta x with a limit. So what limit you want? We want our limit, because here on x-axis you have plotted a time. So this is x-axis. So to which thing you want to do 0? Delta x. Okay, because if delta x will reduce to 0, we will exactly reach at the point where we are interested to calculate the slope. So what is the condition for limit? Delta x tends to 0. So this is the mathematical representation of differentiation. dy by dx is limit delta x tends to 0, and you know how to represent delta y. Okay, how you represent y plus delta x? Function of x plus delta x minus fx upon delta x. So this is the one way to represent differentiation. This is the other way to represent differentiation, and the language we will use for this is differentiation of y with respect to x. What is that limit? Limit delta x tends to 0. We want to reduce this particular triangle. How you reduce the size of this triangle so that you exactly reaches at this point? You have to reduce the size of this base. So delta x tends to 0. Thank you.